Hi and a very good morning to all of you. As you all know, we are going to start the new subject which is biochemistry, and for some batches physiology also combined. So the most important chapter in biochemistry is carbohydrate metabolism, after which comes lipid metabolism and protein metabolism. Okay, you'll understand why is it so important. Now for a dentist perspective, yes, it's kind of basics to know as a doctor, that's it. Okay, if you don't know metabolism, you're not a doctor, that's it. It doesn't have a direct application in dentistry, not even in medicine also. Okay, it's indirect only. So when it comes to biochemistry and NEET and INICET, the thing is that for NEET, it's a subject which is of moderate importance, I would say, because 7 marks come from here. A very small subject when you consider NEET. Now when you consider your BDS examination, it's not a small subject, but for a NEET it's a small subject. Okay, we'll be covering it. No, definitely lots of areas in biochemistry is going to get, especially the pathology part is going to get taken in general pathology, general medicine and all. So in fact, you're going to learn the entire textbook. Okay, but it's not through biochemistry, it's selecting some other subject. Okay, so it's a small subject for NEET. For AIIMS, it is like very less important compared to in physiology. Physiology is more important definitely for AIIMS. For INICET, for AIIMS, it is very less significant so far. Okay, now see. Does it mean that you shouldn't learn biochemistry for AIIMS? No, not at all, because you know the level of competition in AIIMS is very high, isn't it? The level of competition is very high. So what does it mean? It means that even if you miss out a few questions, for example, if 3 questions come from biochemistry and you miss out those 3 questions, you're out. Okay, that's the level of competition in AIIMS. That means you have to study all the subjects for any exam, whether it's NEET or INICET, all the subjects. But now, which to concentrate, and finally in the last 3 days, which are the subjects you have to focus on, that's where the difference comes. Learning, the initial learning is going to be the same for all subjects. Okay, now, considering biochemistry, there are some other specialities also. It's a subject where you have to give number of repetitions. Okay, maybe you have to listen to the lecture twice. Okay, maybe you have to go through your notes multiple times rather than revision. Revision, definitely. What is revision and repetition? Revision is like you're studying today, you're studying tomorrow, you're studying next week and all those. But when it comes to biochemistry, it's a subject where you have to go for lots of repetitions, like pharmacology. Today you have learned carbohydrate metabolism. You have to, maybe you have to repeat the lecture once again, or I would say you have to repeat your notes once again. Okay, your notes once or twice or thrice the same day, not tomorrow. Okay, so don't waste your time in your textbooks, do it more and repeat it as much as possible in repeat your notes as much as possible rather than going through your textbooks. Okay, now other thing for biochemistry, the book, definitely Dental Pulse lectures and academic questions are sufficient. Okay, because you know you're getting very detailed lecture compared to many other academies which they say that you have to refer across, you have to refer Salman Manna, you have to refer Rebecca. The number of lectures provided to them is very little, but you're getting lots of lectures, means you are almost covering the important areas in your textbook also. So, and you need extra time to cover this lecture. Now your friends are there in some other academy and they're saying that I'm referring Rebecca, I'm referring Salman Manna and all those. Tell them we have lectures. Okay, because you need more time for lectures also. Okay, doesn't mean that everything will be covered through lectures, but definitely the basics part which you read in your textbook will definitely be covered. Okay, now those students who are already done biochemistry and physiology in their first round, there are students, okay, who have done it once before, definitely don't waste your time in your textbook, revise. Okay, so far 7-8 subjects are over for you, isn't it? At least 6 subjects are over for you. So then repeat them. Okay, repeat them. For some batches, I know anatomy phase 2 is remaining. So it means the 6.5 subjects. Now this will make 8 subjects. Biochemistry and physiology will make around 7.5 to 8. For some batches, phase 2 is also covered for anatomy. So it makes 8 subjects once in the next 2 to 3 weeks, isn't it? That means you have done half of your, or almost nearing half of your syllabus. Okay, almost nearing. It's 19 means like 9.5 subject is equal to 19 subjects. So you are nearing half, midway. I'll tell you what are the considerations you have to think on about this particular situation of covering the half. Okay, many students are worried and many students are getting more and more confident. So what has to be done? Okay, so let us come on to carbohydrate metabolism. Okay, the basics on carbohydrates, there are glucose, okay, there are like pentose, hexose and all those. Okay, you can do it from across. Okay, and also in your, I think in your dental pulse synopsis also there is a few details given. That is sufficient. Okay, solve some across questions, across or Rebecca. Okay, now again coming back, if you want to solve Rebecca for biochemistry and the Salmon Manna for physiology, then I would suggest you to go with carbohydrate metabolism, lipid metabolism, that's it. And that too the most important questions, okay, recent need questions only. Okay, a little bit on basics on carbohydrate metabolism will also do. Okay, it's simple area, there is not much. Okay, if you want any lecture additionally, you can suggest there is a lecture suggestion group, so you can suggest it there. Okay, if you want a small lectures on some very basic things, be very specific. Don't say that I need lecture on carbohydrate basics. Okay, be very specific what you didn't understand. It should be kind of doubts being asked. Okay, let's come on to the carbohydrate metabolism. Okay, when it comes to carbohydrate metabolism, the most important thing you have to know is liver. Liver is the glucostat monitor. Okay, now why is it glucostat monitor? The major utilization of glucose takes place in liver. Okay, major utilization of glucose takes place in liver, brain and some very important areas, but yes, utilization takes place there. And secondly, if you have deficiency of glucose, if you are not eating, if you are not having your food properly, if you are fasting and all those, there is another mechanism to synthesize glucose which is called glycogenesis, okay, or gluconeogenesis. You will come to that. So all this takes place in liver. Also if you are overeating, if you are eating beyond a limit, what happens is that the excess glucose is stored in the liver in the form of glycogenesis, synthesis of glycose. You come to this. Okay, now just a clinical note I want to give you. Okay, now for example, you are someone who is dieting, okay, and you see that there is no loss of weight. What is the problem? The thing is that your fat is not utilized. For example, yesterday night or yesterday I had very elaborative meals. Okay, yesterday I have overeaten yesterday. So lots of glucose is stored as glycogen. Okay, glycogen. So what happens? Your glycogen store, I don't exactly remember it's not a neat perspective. Okay, just a life. Okay, day-to-day life perspective. Okay, it's around 300 grams or so. So it is being stored in the glycogen. Okay, glucose is stored as 300 grams. Now you are not losing your weight. Why? Because your glycogen stores are immediately utilized, for example. Okay, then you are eating again. That means your fat is not burnt. Now what to do to burn that fat? Hope you are getting what I am saying. You have to first utilize your glycogen which is there in the liver, which takes around 8 hours to 10 hours of fasting, which you can do it overnight also. Okay, 8 to 10 hours. For example, eat today night, today evening 7 o'clock, then eat only tomorrow morning 8 o'clock or 10 o'clock. That means what is going to happen? By the time you reach your morning 6 o'clock, 7 o'clock, your glycogen stores are gone. Okay, and after that, for the next 2 hours, your fat is going to burn a little bit. And if you are exercising, okay, I'm not saying that empty stomach, if you are diabetic and all, don't do exercise in your empty stomach, but otherwise you can do empty stomach, a little bit of exercise, a little bit. You just need to increase your BMR, basic metabolic rate. You don't need to be heavy exercising, 10 minutes, 20 minutes, so that there is no glycogen to use. The brain is going to burn your fat. So the body is going to burn your fat. So liver is a glucose state monitor. Now you understood why it is. It's storing glycogen, okay, and it's also releasing glucose, okay. So this glucose is being utilized for energy in the body by the process called a glycolysis, okay. Now, yes, and it goes further into TCA cycle and all. So what is the first thing you have to know in glycolysis? It's also known as Embden-Meyerhof pathway or EM pathway, okay, EM pathway. Now, it happens or it occurs in cytoplasm. It occurs in cytoplasm. And now you will come to this all this, okay, different processes happens in cytoplasm, some other processes takes place in mitochondria and so on. The byproducts is 4, I would say 3, okay, 3 depends, okay. Now, it can be either pyruvate, you'll come to this, okay, don't worry, just to give you an introduction, or lactate, depending upon the availability of oxygen. If oxygen is available, you get pyruvate. If oxygen is not available, you're going to get lactate. Okay, we'll come to this. ATP, this is the primary thing you want, isn't it? ATP for energy. And NADH. Now, from this, this NADH doesn't produce ATP directly in glycolysis. It goes to mitochondria. It is transported to mitochondria. You'll see again. And there it is used, okay, oxidative phosphorylation is something what is called, and you don't need to go into details of oxidative phosphorylation, but yes, this is used and the electron is transported and from there ATP is synthesized. Okay, that is the next product. Okay, so 3 very important products. One is either pyruvate or lactate, ATP, NADH. Okay, now the next thing which you have to know is about the glucose transport. Okay, glucose transport. Now here you have to know that the glucose is transported. The glucose is transported into cytoplasm of different cells for utilization, for glycolysis to take place, because glycolysis is taking place in cytoplasm. You need to transport the glucose from from the blood circulation at least into cytoplasm. Okay, so for that you have got lots of glucose transporters. So of the liver cells, no. Yes, into different cells. Okay, whatever cell it is. Okay, you just rub that liver cells into cytoplasm of different cells wherever glucose is going to get utilized. Okay. Now there are 2 types of glucose transporters which transport the glucose into cytoplasm for glycolysis to take place. What are they? So based on that, there is insulin dependent glucose transporters, insulin dependent, okay, and there is also insulin independent glucose transporters. So there is insulin dependent glucose transporters and insulin independent glucose transporters. Insulin dependent glucose transporters, you have got 4 of them. Okay, 4. GLUT1 glucose transporter 1, GLUT2, GLUT3, and not GLUT4, GLUT5. So 1, 2, 3, 5, and now even 7 is there. Okay, in your recent books it uses 7, but 7 is not decoded yet. Okay, so study at least 1, 2, 3 and 5. Okay, 1, 2, 3 and 5. Now, GLUT1 is there. I'll give you some clues how to learn it. GLUT1 is there. Now, in your books, especially your across or your books, you'll see lots of areas, okay, lots of description on this. At least you know this much, it's good. Okay, so GLUT1 is there in RBC. So the utilization of glucose or transport of glucose into the cytoplasm of RBC is run by GLUT1. That is what GLUT1 is there in RBC. Platelets and blood-brain barrier. What's the clue here? What did you understand? RBC, platelets and blood-brain barrier. The clue is blood basically. The blood cells, RBC and platelets are blood cells, and next you have blood-brain barrier. Okay, you'll come to this, okay, you'll study this, what blood-brain barrier is in your MCQs. Okay. Now, okay, let me see if someone tells me that you want lectures on blood-brain barrier, then we will see. Okay, it's there. I think it comes in anatomy, brain part. Okay. Not very important, but there are some MCQs based on blood-brain barrier. Now, when it comes to GLUT2, it's pancreas and liver. Okay, it's two-way transporter. They call it as a two-way transporter. Now, pancreas and liver, two-way transporter, so there is something, okay, two. What is this? Now, pancreas and liver, the importance is that it needs glucose to come in and go out of the cytoplasm. Okay, the cells of the pancreas and liver, it needs glucose to enter inside like all other things. Okay, all other cells. It also needs glucose to go outside also. Okay, that means it needs a two-way transport. So that is done by GLUT2. Okay, so two very important areas where two-way transport is needed, and that is by GLUT2. Okay, that's a clue, you can take it here. Okay, now GLUT3, it's coming from this. Okay, it's coming from blood-brain barrier, the brain. Okay, so remember, blood-brain barrier is GLUT1, and into the brain cells it is GLUT3. Okay, into the brain cells it's GLUT3, and placenta. So placenta has got blood placenta barrier. Okay, so that's the clue, you can learn it here. Okay, blood-brain barrier and placenta. Okay, like brain, there is a blood-brain barrier. There is a blood placenta barrier which you have got in placenta. And finally, it's sperm. Okay, where instead of glucose, fructose. Okay, it's not fructose, it's fructose being transported into the sperm cells. Okay, how to learn that? It is the 5 is like S. Okay, so sperm. Okay, 5 and S is looking like same, isn't it? 5 and S. So 5 is sperm. So once again, GLUT1 in RBC, platelets, blood-brain barrier. So basically the clue is blood. GLUT2 is two-way transport. So it's pancreas and liver. GLUT3 is brain and placenta. I don't know. You need to by heart this. Okay. And finally, it's GLUT5, which is sperm. Is 5 is like S. Okay. 5 is like S. So that was insulin dependent transport. Now you will see insulin independent. Naturally, what is left? GLUT4, isn't it? GLUT4 is left. So GLUT4, a few things you have to know. It's insulin dependent. That means it needs insulin for the glucose to transport into the cytoplasm. Okay, this transporter needs the presence of insulin, which is secreted by pancreas, which is very important in utilization of glucose. So it needs insulin for the transport of glucose into the cytoplasm. Of which cells? Heart. Okay, heart, very important. I'll give you the clue for this. Skeletal muscles and adipose tissue. So what are they? Heart, skeletal muscles and adipose tissue. How can you learn it? The clue is the blood is pumped by the heart, so heart is here, by the heart to the muscle, that is skeletal muscle, and fat is burnt. So that's a clue, you can learn it. Okay, blood is pumped, you know it. Okay, this is a normal process which happens in the body. Blood is pumped by the heart into the skeletal muscles. Okay, and you run, fat is burnt. Okay, so that is what the clue is: heart, skeletal muscles and adipose tissue. So hopefully you have learned this. It's a very important areas. You can get questions. GLUT4 is present in what? GLUT3 is present in what? GLUT5 is present in what? So that's the question you can get. Okay, just revise once again and you will learn it. Okay, it's fine. More importantly, just know this GLUT4. Okay, the short forms used for that. The blood pumped by the heart to the muscles and fat is burnt. Okay. Now coming on to the pathway, which is glycolysis or Embden-Meyerhof pathway. What is the first molecule? It's the utilization of glucose. So what first happens is that glucose is converted to glucose 6-phosphate. That means a phosphate is added at the 6th position. Okay, you don't need to go into the chemistry of it, but yes, just to understand, glucose is added at the 6th position, so glucose 6-phosphate. Now, I'll show you the structure of glucose, you'll understand the 6th position very soon. And this is in the presence of two very important enzymes, or I would say one very important enzyme, depending upon the location. We'll come to this. It's either hexokinase or glucokinase. Okay, depending upon the tissue, okay, the site, which enzyme will act where we'll show. Okay, I'll show you. And here, very important to note, one ATP is utilized. Okay, basically, why is glycolysis for? To produce ATP. But you will see that initially there is the energy utilization, definitely, isn't it? There has to be some energy to start the process. So there is ATP being utilized in the level of hexokinase or glucokinase. Okay. Now this glucose 6-phosphate. Now another thing, a kinase, whenever you see kinase, it's either phosphate being added or removed. Okay, please note that. Okay, it's either the phosphate is added or removed. Okay, now this glucose 6-phosphate is then converted to fructose 6-phosphate. Now, you know the glucose is an aldose, which is an aldehyde, and fructose is a ketone. Okay, so it's the functional group is different here. Okay, it's either the CHO, which is aldose, aldehyde and glucose, or COO. Okay, in the fructose, which is a ketose. So that's the difference. The rest all it's going to be the same. Okay, so you will see an extra OH in glucose. So basically it's just a isomerization. So fructose and glucose are isomers. So there is an enzyme called a phosphoglucoisomerase. Okay, so phospho is already here. Okay, phospho is already here. Glucoisomerase. So it's converted to fructose 6-phosphate. So what did we see? Glucose is converted to glucose 6-phosphate by, yes, two kinases there, either hexokinase or glucokinase, and an ATP is utilized in that step. And now there is an isomerization into fructose 6-phosphate. What next? Fructose 1,6-bisphosphate. So one more ATP, one more phosphate is needed, isn't it? One more. So bisphosphate, 2 phosphates, bis. Here is only 1 phosphate at 6th position. Here there are 2 phosphates at 1 position and 6th position. So that means 2 phosphates are, or 1 phosphate extra is added. Again, where does the phosphate come from? So before that, the enzyme PFK, it's a very important enzyme. It's the rate limiting enzyme. Now this is a small controversy, you will come to it, okay, regarding which is a rate limiting enzyme. So it's a most important enzyme. It's the most important enzyme in glycolysis, phosphofructokinase, again a kinase. So what you're going to see, phosphate is going to get added, isn't it what we saw? And this phosphate is coming from, as I've told you, ATP. So these are the 2 steps, 2 very important enzymes, hexokinase, glucokinase, okay, or I would say phosphofructokinase. These are the 2 steps where energy utilization takes place. Now it is going to be energy production. Okay, energy utilization is over. So 2 ATPs are used in glycolysis. That's a prime thing. Because enzymes, they will ask you. Okay, now see, again, you need to repeat it so many times so that it goes in. Instead, there is another way of learning biochemistry. Learn a chart of enzymes, key enzymes. It will not stay. Maybe it will stay there for you till your next month or so. But when it comes to 20 subjects, it will not stay. Okay, by the time you finish your 20 subjects, this is going to be blank if you have learned only charts and if you have not understood the pathways. So please understand the pathways. Don't say that my friends are learning from charts, so they are learning it, they're saying it's better, it's easy. Please understand this. Even if you don't master it, no problem, but understand at least. Okay, understand it. So it's fructose 1,6-bisphosphate. Okay, fructose 1,6-bisphosphate is being formed. So 2 phosphates are added into fructose. Now what next? Now, as I told you, these are aldoses or ketoses. Okay, so now an enzyme called aldolase will act on this fructose 1,6-bisphosphate and split it into 2. Okay, if you know, glucose is a 6-carbon compound. This is split into 3-carbon and another 3-carbon. Okay, very typical example of 3-carbon compounds which is happening in glycolysis is glyceraldehyde 3-phosphate. Okay, it's an aldehyde again. Okay, it's glyceraldehyde 3-phosphate. Okay, and dihydroxyacetone phosphate. So an aldehyde and a ketone. So that's okay. This is an aldehyde and a ketone or acetone. Okay, both of them sharing 1 phosphate each. Okay, so it's a 6-carbon compound split into 2 3-carbon compounds. Now here it can be interconvertible. See this. Okay, these are interconvertible by the enzyme called isomerase. Again, these are isomers. Okay, glyceraldehyde 3-phosphate G3P you can call it, or DHA. Okay, DHA, dihydroxyacetone phosphate, DHAP in some books. Okay, DHAP. So just write it down there. It's G3P and DHAP. Okay, so these are interconvertible. Just know here there are an aldehyde and a ketone formed, and this is interconvertible. So this is where you're going to see two processes taking place side by side. Okay, the ATP production. Now we're going to discuss one. Okay, you'll see later on that this is also converted to this, that is dihydroxyacetone phosphate is converted to glyceraldehyde 3-phosphate, and from this same process which you're going to describe is going to repeat again. Okay, so that you get more ATPs. Okay, I'll explain this. Don't worry if you're not understanding it now. So now the next step is we are going to concentrate on one compound, glyceraldehyde 3-phosphate, and what happens to it, and the same applies to the same dihydroxyacetone phosphate because it is converted to the glyceraldehyde 3-phosphate. So let us see what is going to happen. Glyceraldehyde 3-phosphate is converted to a very important compound. Okay, the most important compound you have to remember in glycolysis, I would say, is 1,3-BPG, 1,3-bisphosphoglycerate, 2 phosphates. Okay, now again a phosphate is added which is not an ATP phosphate. Luckily for us, so there is no utilization, just an additional phosphate. You know that body has got phosphates. So it's 2-phospho, that is 1,3-bisphosphoglycerate because it's glyceraldehyde. So aldehyde is becoming an acid. So if you know the process, how is aldehyde becoming acid? It's CHO, which is an aldehyde. Okay, from here there will be other compounds also, CH2 and all. So because it's an organic compound, so this is an aldehyde group. From here hydrogen is removed, another hydrogen is removed from another group. So 2 hydrogens are removed, I would say 4 hydrogens are removed. Okay, 4 hydrogens are removed, and from different areas, maybe this or anywhere, but anyway H will go from the CHO. You don't need to learn this, just understand it. And this, what is left is CO, and OH is added. So you get aldehyde converted to carboxyl group, which is an acid group. Okay, which is an acid. Okay, that's how aldehyde gets converted to an acid. Okay, so the same happens here. An aldehyde is getting converted to an acid. Okay, so glyceraldehyde 3-phosphate becomes 1,3. So 1 phosphate is added. 1,3 aldehyde become 1,3-bisphosphoglycerate. So what's the enzyme now? See, the enzyme is glyceraldehyde 3-phosphate dehydrogenase. Hydrogen is removed. Enzyme. Okay, same thing, glyceraldehyde 3-phosphate. Okay, G3P into glyceraldehyde 3-phosphate dehydrogenase. Okay, the enzyme is dehydrogenase. Now, where does this hydrogen atoms go? You get NADH. This is the key compound which will now go into the oxidative phosphorylation. While we study the TCA cycle, you'll see the oxidative phosphorylation, and there it is utilized for ATP. So this is where hydrogen comes from, the aldehyde conversion to acid. Now this compound is very important, 1,3-BPG. You're going to soon come across something known as 2,3-BPG. Okay, and you will come across the same thing in physiology also, 2,3-BPG. I'll tell you what's the significance of it. So it's 1,3-BPG. Okay, 1,3-BPG, and this 1,3-BPG is now converted. So hope you understood what has happened so far. Glucose to glucose 6-phosphate, a very important enzyme, ATP utilized. Then comes fructose 6-phosphate, which is isomerase, not very important, but yes, the key enzyme comes. Again, a phosphate is added, you have fructose 1,6-bisphosphate. Now this is split into 2 3-carbon compounds. Again, this 3-carbon compound continues as an acid now. Okay, and thus you have got dehydrogenase, and this dehydrogenase is being utilized for production of NADH, a very important compound. So hope you got this much. Now continuing further, you have got 1,3-bisphosphoglycerate, from which 1 phosphate is removed. It's 1,3, isn't it? It becomes just 3. Okay, 1,3 becomes 3. Now, and it's same. So instead of bis, you have got that bis also removed. Bis means 2. So 1,3-bisphosphoglycerate becomes 3-phosphoglycerate, 3-PG. So 1,3-BPG becomes 3-PG. If you want to remember it like that, you can write it there. Okay, 1,3-BPG becomes 3 PG, okay, 3 PGs. Or if you can learn it like this, it's also good. So now the enzyme is phosphoglycerate kinase. So again a kinase. So we saw 2 kinase already, hexokinase and glucokinase, and PFK1. Okay, we are going to see PFK2 very soon. Okay, in regulation of glycolysis, PFK1. So these kinases what were they doing? They were removing, or they were adding phosphates, or they were utilizing ATP. Now you're going to come across a very important kinase, phosphoglycerate kinase, or phosphoglycerate kinase, and this is where ATP is going to be started to get formed. So kinases are the ones which either adds or removes phosphate, or utilizes or forms ATPs. Okay, utilizes. So far we saw 2 kinases which utilized ATP. Now you're going to see 2 kinases which gives ATP. From where is this coming? 1,3 becoming 3. Okay, 1,3 BPG becoming 3 PG. So you're going to get the ATP here, which is from the ADP. So the first ATP is formed. What is the step? Very simple. 1,3 BPG becoming 3 PG. Okay, if you can't by heart this. Okay, if you can't learn it in the process, by heart this. But before this, you have got NADH being formed by the dehydrogenase. So what has happened is dehydrogenase forming NADH, okay, and now you have got a kinase forming ATP. Okay, you have to repeat this many number of times, okay, otherwise you will forget it. Now 3-phosphoglycerate, not much is happening, becoming 2-phosphoglycerate. So the position of phosphate is changing, okay, and the enzyme is also not very important, phosphoglyceromutase, a kind of isomerase again, phosphoglyceromutase, not very important. Now 2-phosphoglycerate is now going to convert into a very important compound called a PEP, phosphoenol pyruvate, okay, phosphoenol pyruvate, by the enzyme of a very important enzyme called enolase. You will see that this is the enzyme where fluoride is influencing. I'll tell you this, okay. Phosphoenol pyruvate, so 2-phosphoglycerate, 2-phosphoglycerate, so 3 PG becoming 2 PG. So once again, before that, hope you remember, 1,3 BPG becoming 3 PG, okay, then 3 PG becoming 2 PG, okay, then you have got PEP, again P only, but phosphoenol pyruvate. Now you know what, very simple, isn't it? You got phosphoenol pyruvate, you're going to get now pyruvate, which is the last product in glycolysis. Luckily glycolysis is over, isn't it? So into pyruvate. Again, what's the enzyme? Phosphoenol pyruvate. So I read pyruvate kinase. The second ATP is going to come. So 2 enzymes where ATP is utilized are kinases, hexokinase, glucokinase, either of them. Phosphofructokinase. Okay. So there are 2 ATP utilization. Then you saw phosphoglycerate kinase, PG, the PG kinase. Okay. Phosphoglycerate kinase where 1,3 BPG is converted to 3 PG. And finally, you have got phosphoenol pyruvate to pyruvate, where you have got pyruvate kinase. Okay, you're going to get A, which is an irreversible. I'll come to this. ADP to ATP. Again, the ATP is formed. Now, we saw 2 kinases, isn't it? 2 kinases. One kinase is here, phosphoglycerate kinase, and another kinase is here. And these are the 2 steps where ATP is formed. Now, the importance is that this is irreversible. It can't go back, okay. Here this is reversible, it can go back to the previous product, okay. Now what is the importance of this? This is a very important regulatory steps. Besides others which we will learn, there's a very important regulatory steps in glycolysis. Once this product is formed, it can't go back, okay. So it's a regulation. Once that product is formed, it can't go back means it's a regulation. Whereas, okay, they will ask you the question like this. A reversible step in glycolysis where ATP is formed, only one, okay, that is this, okay, and there is an irreversible step where ATP is formed, pyruvate kinase. Enzyme is what is important there. The enzyme involved in the irreversible step for substrate level phosphorylation. What is that? Substrate level phosphorylation means this is the substrates. Okay, sorry, this is the substrate which is converted to its product, and there is a phosphorylation happening where ADP is converted to ATP. Okay, that is ADP is adenosine diphosphate, adenosine into triphosphate. So it needs a phosphorylation to happen, and this phosphorylation is at a substrate level. Okay, substrate level. There is another phosphorylation, I'll tell you very soon. This is substrate level phosphorylation. So they will ask you irreversible step where substrate level phosphorylation takes place. It is this step, okay, pyruvate kinase. And an reversible step where substrate level phosphorylation will take place, it is this. Okay, so basically what they mean here is ATP production. So I'll just repeat it once again for you. Here, the first thing, glucose is converted to glucose 6-phosphate. So definitely now you know the kinase being acting there where ATP is being utilized. Okay, glucokinase, hexokinase. Glucose 6 into fructose 6. Understandable? Okay, then you get fructose 6 into 1,6, so again kinase is acting, PFK1 is acting there, ATP is being utilized. So two steps where ATP is utilized, easy. Then you have got 1,6 phosphate is being added, you got fructose 1,6 phosphate which is getting converted or splitted, I would say, under the influence of the enzyme called aldolase into the glyceraldehyde 3-phosphate and dihydroxyacetone phosphate or dehydroxyacetone phosphate. Now, very important, if you don't solve MCQs, this will not stay behind. So some students saying me that, so I finished all the carbohydrate metabolism and I did, or I would say I finished all the biochemistry and then I'm going to solve dental pulse. It's not going to stay there. Go do it side by side. Now the best part of this biochemistry is that if you're solving from either Rebecca or across, the thing is that you've got glycolysis, so you can once finish your glycolysis pathway, you can solve those questions. Even if you forget that, you know the questions what are going to come. So then you solve dental pulse, it becomes very easy. Then learning pulse also becomes very easy. As I've told you previously in one of my voice note that many students, many toppers, they say that initially we did across or Rebecca or someone manna, but then we forgot it, we did only dental pulse. Now the importance of doing Rebecca at this level is that you can individually learn each pathways. Okay, glycolysis pathway separately. So please do, after this lecture, probably glycolysis will be there in 2 lectures. So after this lecture, please go through the Rebecca if possible. Okay, or do the questions of at least glycolysis on your dental pulse. Okay. Now it's not very important that you read the explanations. Please don't do the explanations of across, Salmon Manna or Rebecca. You're going to waste a lot of time. Explanations from the dental pulse only. And please make sure that you are not omitting dental pulse. Dental pulse is the key, okay, for your entrance preparation. I've been saying this multiple times, why? So I'm not going to repeat it here now. So glyceraldehyde 3-phosphate is getting converted to dihydroxyacetone phosphate. And now, so that's 3-carbon compound. Now glyceraldehyde becomes an acid. So dehydrogenase is acting up there, and as a result 2 hydrogen atoms are removed, and these 2 hydrogen atoms are gained by NADH. You're going to get NADH, please note. Now that is the 1,3-BPG is formed, a very important compound, converted to 3-PG, so phosphate is removed. So what is going to happen? The kinase is acting, which is a reversible step, you know now, and you're going to get your first substrate level phosphorylation ATP, and then 3-PG is converted to 2-PG, very easy, and 2-PG into phosphoenol pyruvate by the enzyme enolase, and then you have got final step, phosphoenol pyruvate to pyruvate. Now, what happens for pyruvate? Depends upon if there is availability of oxygen or not. Okay, depends upon if there is availability of oxygen or not. It can either go into an aerobic glycolysis if there is oxygen available, or it can go into an anaerobic glycolysis. So we'll see that. Okay, if there is no oxygen, please note, if there is no oxygen, you will see that pyruvate is converted to lactate. You are running very fast, you are not getting enough oxygen, there is lots of pyruvate is converted to lactate, and you feel that your muscle is cramping. Why? Because of this lactate being produced a lot in your muscles. Okay, muscles utilize the glucose a lot. Okay, so that's why you get the cramping, and you rest sometime, you get enough oxygen, you relieve that cramping, isn't it? So it's basically the anaerobic glycolysis, which is not very efficient, but in the less oxygen environment, you're going to get anaerobic glycolysis, which is pyruvate to lactate. Okay, what's the difference? I'll come to that. ATP production is much lesser. Okay, it's not going outside cytoplasm. Everything has happened within cytoplasm. So if it is not going outside cytoplasm, no NADH is utilized. Okay, no NADH is utilized. Though NADH is formed, the previous steps, it's not utilized because it's not getting oxygen. It needs oxygen for the NADH to get converted to ATP in the mitochondria, because mitochondria is where all those things taking place. Okay, so we learned this especially in citric acid cycle. So lactate by the enzyme called lactate dehydrogenase. Why lactate dehydrogenase? Because these are interconvertible. Okay, pyruvate to lactate is interconvertible. Okay, so that's why lactate dehydrogenase. Again, hydrogen is removed. Okay, pyruvate to lactate. Okay, so lactate dehydrogenase in the absence of oxygen. Okay, and here, yeah, very importantly, NADH is converted to NAD. So that's why whatever NADH we produced previously, okay, NADH which we produced previously, it is going to get utilized here and it is going to convert into its original product, which is NAD. Okay, so what is the importance of this product? If glycolysis has taken place and lots of NADH is being converted, NADH is being formed, you have lots of NAD being utilized. Isn't it? NAD being utilized here because NADH is coming from NAD, isn't it? So NAD being utilized, you need it to be replenished. So that is coming here from here. Okay, NADH to NAD. And this NADH, as I've told you, it goes back to this step. Okay, it's not this step, sorry. It should go here. Okay, it's to this step. Okay, NAD. So this NAD is being again utilized for the next glycolysis. So very important thing which has happened here is more than lactate production. What has happened really is you have replenished the NAD. And you don't need, now in anaerobic glycolysis, you don't need NADH also because there is no oxygen to be for utilizing this NADH for ATP. So that's one very important thing. Now, if you have oxygen, what's going to happen? In the presence of oxygen. Okay, in the presence of oxygen, you get acetyl-CoA. Now, this is what is going to the TCA cycle. We're going to see that. Okay, in the presence of oxygen, you get acetyl-CoA, very important enzyme, pyruvate dehydrogenase. Okay, I'll tell you, it's a very important enzyme. We'll go in depth of it. Okay, so pyruvate dehydrogenase. Remember, the process here is not dehydrogenation. Okay, it's different, but as of now, just learn that pyruvate is converted to acetyl-CoA in the presence of oxygen into pyruvate dehydrogenase. Okay, pyruvate dehydrogenase, and here again NADH is formed. Okay, here again dehydrogenase. So there is some dehydrogenase activity taking place. Okay, where you get NADH. Remember it like that. Okay, so that's in the presence of oxygen, and this acetyl-CoA, as you all know, goes to the TCA cycle. Acetyl-CoA going to a TCA cycle. So that's the process of ATP production. Now, one more thing I just want to tell you, that this green one, which is being covered by green one, pyruvate into lactate, is called anaerobic glycolysis. Anaerobic glycolysis, whereas this one, which is happening in mitochondria, okay, this is called aerobic glycolysis. Okay, aerobic glycolysis or a continuation of aerobic glycolysis. Now, very important you have to note here is that NADH is being formed. Okay, remember that one NADH is formed here. Okay, now the same thing happens for this also. Okay, same thing for dihydroxyacetone phosphate. You will see that this again goes into the glyceraldehyde 3-phosphate, where it gets converted to the pyruvate, and pyruvate continues as either of this pathway, acetyl-CoA, NADH is formed. Okay, so same thing, it's a repetition. So basically what we saw is that 2 ATP being utilized in the initial steps. Okay, then you have got splitting of fructose 1,6-phosphate into 3 carbon compounds. This is very important, where you get 1,3-BPG, where NADH is formed in its formation. Okay, and then you have got 2 kinases where 2 ATP is being formed. Okay, then after that it depends upon availability of oxygen into lactate or acetyl-CoA. Okay, and here also NADH is formed. Okay, here also an NADH is being formed. Now, next we are going to come on to two very key enzymes which we have to go into little details, okay, and which is hexokinase glucokinase and the pyruvate dehydrogenase. There's also the enzyme which we studied, that is PFK, which we will see in regulation. So here we are going to see the two enzymes which is involved in conversion of glucose to glucose 6-phosphate, and in the end we also see the pyruvate dehydrogenase. So hexokinase and glucokinase, I'm going to show you a chart. So you know the step now. Glucose converted to glucose 6-phosphate is the role of this enzyme, okay, which phosphate is added and ATP is being utilized. So as you could see here, there is hexokinase and glucokinase are two different enzymes. So there's a comparison which you have to know. Okay, the comparison is hexokinase, please note, is there in all tissues, hexokinase, whereas glucokinase, so glucose is an hexose, there are other hexoses also. So glucokinase is seen only in liver. So the glycolysis in liver takes place under the influence of glucose. So glucose, glycolysis, liver, direct connection. Whereas in all other tissues, including the brain, it's the hexokinase, a general enzyme. Okay, whereas in liver, you have got glucokinase. You will see the importance of that very soon. Now, as the name suggests, glucokinase will act only on glucose. Okay, hexokinase will act on all or multiple hexoses. Okay, multiple hexoses including the fructose. Okay, including the fructose, it can act on any. Okay. So let's act on multiple hexoses. Now, glucokinase has got high Km value. That means it needs more glucose for its action. Okay, directly saying. And this has got low Km value. Now, which means for glucose to be utilized in liver, there should be more glucose concentration to be utilized in liver. Whereas if you want glucose to be utilized in brain, okay, you need low glucose concentration. We're going to come on to Km value. Okay, so it's basically Km value means how much glucose is needed for the enzyme to get activated or to get acted upon. Okay, in liver you need, that means what? Brain can work on even small glucose and liver needs heavy glucose to be working. So if you have very little glucose in your body, who will use it? The brain will use it, isn't it? The brain will use it, other tissues, because naturally other tissues will go back. Okay, we'll say, okay, brain use it. So that is very important, isn't it? That's very important that even at low concentration of glucose, you need brain to be using it. Okay, so let's come on to the Km value. So Km value, what's the definition of Km value? Km value is a substrate concentration at which, that is a glucose concentration at which. So basically Km value is directly linked to the how much glucose is there. That's what I said. Okay, Km value is a substrate concentration at which half of the enzyme's active sites are saturated with the glucose or substrate. Okay, I'll show you. Okay, substrate concentration. So Km is substrate. Okay, so Km is substrate concentration. How much glucose is there at which half of the enzyme's active sites are saturated with the substrate. I'll explain this. Okay, that means half of the maximum velocity is reached. When half of the active sites are involved, half of the maximum velocity is reached. When full substrates are attached onto the enzyme, full velocity is reached. Okay, that's what is Km value. Now, let us consider two examples here. Here, you have got a very little concentration of glucose. Just imagine there is a few glucose. These red dots are few glucose out there. Okay, few glucose out there. Now, so about whom are we talking about? Hexokinase, because hexokinase needs only very little glucose, isn't it? So the enzyme, this is enzyme, the hexokinase, where half of its active sites are attached with the glucose. So this is the glucose, the red one, and the active sites, you can see that cup kind of thing. Okay, there. Okay, so that's half of it is being filled with glucose substrate, and half is free. Half of it is free. That means, what did we say about the Km value? Substrate concentration. This is substrate concentration at which half of the enzyme's active sites are saturated with the substrates. Okay, And this leads to what is known as reaching the half of the maximum velocity. This is what is Km value. Now let us take the second example of glucokinase. It needs lots of substrates. For what? For the same thing to happen. Okay, for same thing, that is half of its active site. So it's only 4 sites are involved in both the cases and 4 sites are free. But here for the hexokinase it requires very little glucose. For glucokinase it requires in the liver, it requires lots of glucose for this to be happening. That means for reaching half the maximum velocity. That means what? Hexokinase require very little glucose to reach its half of the maximum velocity. Glucokinase require lots of glucose to reach its maximum velocity. That means the hexokinase is very much affectionate to glucose. Okay, the affinity of hexokinase is high towards glucose. Okay, so that's what it is. If I want to give you a remote example, if your parent loves you, even if, I don't know how much is it really applicable in our society, but there are societies where this happens. Okay, if your parents, you bring very little money, you bring monthly 1,000 rupees and your parents love you, that means the affection of your parent is very high. The money is just glucose. Okay, but if they need 1 lakh rupees, then only they love you, means your affinity of your parents is very low. That's one thing. Okay, so that means Km value is inversely proportional to enzyme affinity. That means Km value is what? Substrate concentration. Km value definition is substrate concentration. That means the lesser the substrate, more the affinity, the more the substrate, less the affinity. Okay, so Km value is inversely proportional to the enzyme affinity. Now, analogy I've told you, the lesser the money, the more affinity. Isn't it? The lesser the money, the more affinity. I told you it's a remote example. Okay, because less money, more affinity. Think of that way. More money, less affinity. Okay, think in that way also. Basically, you have understood the concept. Now what is the significance? I've told you already. Significance is that when glucose concentration is low, who will act? Hexokinase will act. Where is hexokinase? In all tissues, including brain. Okay, so that is what, when the glucose concentration is low, liver cannot use it because it needs higher Km value. It has got a higher Km value. So who will use it? It's diverted to the brain so that it use it. Okay, it's the efficiency of the brain to use it. That's the importance of Km value. Okay, finally we come across the last part, which is it is inhibited by, it is inhibited by glucose 6-phosphate. Who? Hexokinase. And is not inhibited by glucose 6-phosphate, it's induced by glucose. Okay, so one is inhibited by glucose 6-phosphate, the other is induced by glucose, not glucose 6-phosphate, I would say, glucose, and it is not inhibited by glucose 6-phosphate. Okay, so we'll come to this, we'll understand this, how it is. Okay, so remember, hexokinase is inhibited by G6P, glucokinase is induced by glucose through insulin. Okay, we'll come to this. Now, just see this image. If glucose in the liver is very high, okay, glucose in the liver is very high, what is going to happen? Glucose will help in the formation of insulin. Okay, it will help in the formation of insulin, or more insulin is formed. If the liver glucose is very high, more insulin is formed, and this insulin will stimulate glucokinase, so that glucokinase converts all the high amount of glucose into glycolysis and into ATP. Okay, that is what it is. Okay, if the liver glucose is high, in the liver is what you have seen glucokinase acting, isn't it? So if the liver glucose is high, it stimulates the production of insulin, and this insulin will stimulate glucokinase. On the other hand, glucose 6-phosphate, which you saw, does something else. It inhibits, I'll tell you why it inhibits. It inhibits hexokinase. There is lots of glucose 6-phosphate. It will inhibit hexokinase. So hope you understood. If there is lots of glucose, it will stimulate glucokinase. Okay, stimulate glucokinase. If lots of glucose 6-phosphate, it will inhibit. Remember, it's different. The first one is stimulation, the second one is inhibition. So it inhibits hexokinase. Now, why is it so? So this one you got. Okay, regarding the glucokinase you got, because lots of liver glucose, so it has to stimulate the glucokinase for the glycolysis to take place. Otherwise, no glucose will be simply sitting there. Now, on the other hand, in the liver, on the other hand, glucose 6-phosphate, there is one thing, it can enter. Okay, please note it down there. You will understand it better as we go on. Glucose 6-phosphate, besides going into glycolysis, okay, all these pathways and ATP production, it can also enter some other pathways. Glucose 6-phosphate, remember, you're going to see this. It can enter glycogenesis, where glycogen is formed, glycogenesis, okay. Glucogenolysis, which is breakdown of glucose. So you will see this glucose 6-phosphate in both the pathways. Okay, that is in glycogen synthesis and glycogen breakdown, glycogenesis and glycogenolysis. Okay, gluconeogenesis, which is new glucose being formed from other compounds other than glycogen. So one way to form glucose is from glycogen. Okay, one way to form glucose is from glycogen. Other way is from other compounds including amino acids. Okay, which we will see. So that's again the intermediate molecule is glucose 6-phosphate there also. Just write it down, you will see it. Okay. Now also it enters into the pentose phosphate pathway. It can enter either of this pathway once it is formed from glucose to glucose 6-phosphate in the presence of hexokinase. Okay, it can either enter anywhere. Okay, it has got free entry into anywhere. Now, what the role here is? The role here is, if there is lots of glucose 6-phosphate, lots of glucose 6-phosphate, what needs to be done? It should not. If lots of glucose is broken down to glucose 6-phosphate, what should happen? Should all the glucose be burned out? No, it should be diverted to some other pathways. So for that, you need to stop this in other tissues and let the liver work and let it convert into other compounds including glycogen. Hope you got it. Now, if there is lots of glucose in the liver, okay, what it can do is it can use insulin and glucokinase and produce energy. Now, in all the tissues, if you have got lots of glucose, all the tissues means hexokinase. In all the tissues, if you have got lots of glucose, it gets converted to glucose 6-phosphate. The body says, now see, let's stop glycolysis for the time being by inhibiting hexokinase. Okay, let's stop it and let us divert it into some other pathways, especially for the synthesis of glycogen, so that you can store it. So, for glycogenesis to happen, what should be there? The hexokinase should stop its activity. Otherwise, the glucose will burn and it will follow this pathway. So it's stopping the activity there, and it is helping the. Okay, there is one arrow mark extra came here. Just forget it. Don't worry about it. So thus you have glycogenesis now taking place. Okay, this glucose 6-phosphate is getting converted to glycogen. Okay, you'll see the glycogenesis very soon. So hope you got how it is. The glucose can directly stimulate or indirectly stimulate glucokinase, whereas the glucose 6-phosphate can inhibit hexokinase. That's the key here. Okay, so once again, very quickly, hexokinase is there in all tissues. You know now why. In brain, glucokinase only in liver. Okay, acts on multiple exosomes. Glucose, the name suggests, low Km, low substrate is needed, low glucose is needed, whereas high Km, it's about 1000 milligrams per ml is what they're saying. Inhibited by glucose 6-phosphate, we saw that, okay, this one, okay, and this is not inhibited, the glucokinase is not inhibited, whereas it's induced by glucose in the presence of insulin. Okay, that's one enzyme. Let us go on to the second enzyme. Now it's a little confusing, biochemistry is a little confusing, but once you understand, you can score well, a subject where you can definitely score well. Okay, where your rank will jump. This is how small steps, remember I told you, it's that small steps which will take you to your success. It's not a huge jump all of a sudden in the last 2 months. That's not. Small steps, little by little learning, little by little revising them again and again, and slowly by slowly you will start building confidence, and that's where you reach, especially the average students. Okay, the new the repeaters or the first time repeaters or interns, you need to take small steps. Don't worry about a lot of pending and all those. Okay, pending will be there. Whatever you do, pending will be there, no doubt. But the thing is that just keep going till the end. You're not going to lose anything, especially interns. Okay, basically you have time. Okay, don't think that, oh my God, if I don't get an internship, what will I do? It's not. Success doesn't come easy, guys. Okay, you have to really work hard, especially into government dental college. It's not easy. You can't say that, okay, I want to get it in internship only. It's a kind of, some people's luck, I would say, and effort, definitely. Okay, some people tell me, sir, I'm an intern, I'm not getting time at all because I have to go to my clinics and to my college, and evening I go for clinics, so I'm not getting time, or I want to sleep, I want to play around. No. If you want an internship, you have to really work hard, at least from now onwards. You have to somehow, not that you have to finish all your topics absolutely well, it is not like that, but really work hard day and night, whenever time is there, work hard, put efforts till the end, no matter how much confidence you have, no matter how much you are, how much knowledge you have gained, nothing, just put efforts till the last day and you'll get it. Applies to the non-interns also, but for interns definitely it's more more important because the time available for you is little less. Now let us go on to the second enzyme, which is the pyruvate dehydrogenase. Okay, pyruvate dehydrogenase. Now the second enzyme we're going to come across, as you all know, is pyruvate dehydrogenase, which converts pyruvate to acetyl-CoA in the presence of oxygen. Okay, we have learned this. Okay, we'll come across this cycle again and again so that it stays there. So two very important enzymes. One we saw, hexokinase, glucokinase. Now this pyruvate dehydrogenase. Now this enzyme has got, three enzyme part. Okay, this enzyme complex has got, I would say, it's an enzyme complex, has got 3 enzymes and 5 coenzymes. Coenzymes helps in the activity of enzymes. Okay, it stimulates the activity of enzymes. We'll come to that. So what are the three enzymes here? 3 enzymes are decarboxylase. Okay, decarboxylase, removing the carboxyl group. Okay, acetylase, that is adding the acetyl group. Okay, then dehydrogenase. You don't need to go into details of that. Dehydrogenase, which is the typical name of this enzyme, dehydrogenase. Okay, dehydrogenase is there. Now they'll ask you, they'll give you these 3 options. Or one more option, phosphorylase. Okay, or methylase, or all those they'll give you, and they'll ask you the enzyme activity of this pyruvate dehydrogenase involves all these except, so that will be the exception. So decarboxylase, okay, acetylase and dehydrogenase. Okay, so decarboxylase, acetylase and dehydrogenase. Now it's the decarboxylase which is taking down the steps of converting the pyruvate to acetyl-CoA. So they'll ask you that also. Pyruvate to acetyl-CoA involves the action of which enzyme in PDH complex? It is not a dehydrogenase. I told you, remember, it's the decarboxylation reaction. It's the decarboxylation, just for your knowledge. Okay. Learn it if possible. Okay, you will come across this, you will see MCQs related to this and you will learn it better. It's not very easy. See, you are learning this cycle, it becomes very difficult unless and until you solve MCQs multiple times. That's the importance of solving here across. Again, you solve the similar MCQs in your dental pulse. Again, you come across some of them in your the academic questions. Then again, when you're solving your daily boosters, you come across it later on. Then again, when we are giving your grant test, you come across it again and again. So that is how you learn. Okay, it's not directly today. Some students think that it's so difficult to learn, biochemistry, how will I be able to learn it? No, it's very difficult. It is not staying there. It's not going to happen all of a sudden. You're going to come across and solve more and more so many MCQs that slowly by slowly you start learning. Don't worry about at this stage. The Intelligent people are those who just keep working on. Okay, so that's 3 enzymes. Now 5 coenzymes. What are they? The 5 coenzymes will include. Now before that, you have the mnemonics, liver never fails. So before that, okay, there's another MCQ you can remember is DAD. Okay, DAD, decarboxylase. Another mnemonics, DAD, decarboxylase, acetylase, and dehydrogenase. For 5 coenzymes, it is liver never fails clearing toxins. Okay, you know the function of liver is what? Is to clear toxins. Okay, and liver is associated with glycolysis, so that's how you can remember. Liver never fails clearing toxins. Now, what are that? L is for lipoic acid, so liver is for lipoic acid. Never is NAD. Now, NAD is associated with a vitamin, which is vitamin B3 niacin. Okay, this NAD means nicotinamide adenine dinucleotide, and B3 is nicotinamide. Okay, so you'll come across this in vitamins when we learn vitamins. So NAD is associated with the vitamin B3. Okay, then you have got FAD, which is associated with riboflavin. So flavin adenine dinucleotide. So flavin, FAD. Okay, which is vitamin B2. Okay, then so that's fails. Okay, FAD. Then you have got coenzyme A, this is clearing, and the vitamin associated with coenzyme A is B5, pantothenic acid. Okay, somehow learn it right now. You'll come across this again in vitamins, so you learn it better. Okay. Then finally toxins is TPP, thiamine pyrophosphate. So thiamine means B1, isn't it? Thiamine is vitamin B1. So liver never fails clearing toxins. Lipoic acids, NAD, FAD, CoA, TPP. Vertical learning. First that. Okay, learn that first. Okay. Then it's B3, B2, B3, B2, B5, B1. So 3, 2, 5, 1. If you can remember it like that, remaining, when we learn vitamins, I'll tell you how to learn these names. Okay, how to learn these names associated with the vitamins. So it's 2, 3, 2, 5, 1. Okay, so if you remember, liver never fails clearing toxins, and 3, 2, 5, 1. Now, this there is a very important role in thiamine in alcoholics. Okay, this is a question related to this. That's why I'm saying this. So the thiamine absorption is very low when you drink lots of alcohol. So the absorption is low in alcoholics. So what's the influence of that? If thiamine is low, this is a coenzyme for which enzyme? Pyruvate dehydrogenase. So the conversion of pyruvate to acetyl CoA will not take place, means less energy production. Okay, so if there is an alcoholic, okay, for an alcoholic the problem is what? There is less thiamine, so less energy. That's why you see the alcoholics people are always lethargic. Okay, you see them sleeping, tired always. Why? Because of this enzyme is not acting properly, because coenzyme is needed, and this coenzyme availability is a big problem there. So 2 enzymes we studied. One was hexokinase, glucokinase, and now we have got pyruvate dehydrogenase. So okay, 3 enzymes and 5 coenzymes. So it's DAD, decarboxylase, acetylase and dehydrogenase. Then you have got liver never fails clearing toxins, that is lipoic acid, NAD, FAD, coenzyme A, and TPP. Okay, they can ask you all of the following are coenzymes except, or they can even twist and turn. So if you know the concept here, it's going to be super easy. And yes, one more thing about vitamin B1. Okay, so by that you come and end to this part also. Let's go to the next. Now before that, I want to tell you a very important information that I received a message from a student. As you all know, for most of the batches, the second grand test is over, isn't it? 2 grand tests are over. So the student told me that I have been learning very well, but my grand test 1 marks are very good. I'm very happy. But my grand test 2 marks are very low. What will I do? Or I've lost my confidence in the due to grand test 2. What will I do? Now see, the thing is that don't bother too much at this stage in your marks. As I've told you previously, keep putting efforts. Your marks will come down. Subject varies, you know. When you have got, see again, grand test 1 was put easy. 1 to 2 was made a little difficult. So don't worry that, don't compare your previous marks with this marks. There are students who do this a lot. Okay, my microbiology marks were very good, but my biochemistry marks are very low. 2 different subjects, Baba. And you're learning it in 2 weeks. So don't, if you're a first year student or a second year student, yes, if that goes wrong, then it's fine. You are learning it so quickly, how can you compare? Maybe there is statistics given in your app, okay, but don't apply it at this stage. You will do it in the final test series, okay, the final revision or final mock exams and all. At this stage, just compare, but don't worry. If you want to compare it, no problem, but don't start worrying about it, okay. Don't lose confidence at any stage of your preparation. If you lose confidence, you're going to slowly go away from your preparation. So please don't do that. The exams are different, okay, the exams are different patterns, different difficulty levels involving different subjects. Perio is one subject where you have got lots and lots of things to learn. Okay, general pathology is another subject where you can get lots of questions. So it's all new. Now next is going to involve orthodontics, the next grand test. Again, a huge area. You're studying in your UG level this much. Okay, and when it comes to your PG level, or I would say in your entrance level, it is this much. Again, lots of questions, new questions can come. Don't worry on that. Are you doing your basics well? That's the key. If you're doing your basics well, don't worry about new questions. New questions are just to give you new questions. That's it. It's not going to test your knowledge. Okay. Just see how much wrong you're going in older questions and try to correct it. And learn new questions. That's it. New questions, you're missing it out, no problem. But if you're making mistakes in what you've learned, that you just improve. And don't worry again. Improvement, that's the key. Keep on improving, that's the key, and nothing else. Okay. So let's come on to the ATP production part again.